Good evening to all of you. Welcome you guys. Welcome you all. Welcome you guys. Welcome you all. How you are doing everybody? कैसे हो सभी लोग? Welcome you all. So do join the session fastly, everybody. कैसे हो सभी लोग? I hope we are live. Yeah, first of all, do comment in the comment section whether this audio video is clear to everybody. Do comment in the comment section whether this audio video is clear to everybody. Right. Unacademy Unacademy आपके लिए लेकर आया that is 60% of discount. Yes, it's true. The 60% of discount आपको मिलने का chances है. And as per the request of the student, the offer has been extended. Offer has been extended as per the request of the students, and you utilize this opportunity before it going to expire. चलो आज का सेशन हम शुरू करेगा. And the Unacademy is providing another great opportunities. The student who got the GATE 2025 में rank मिला, so in top 100 वाला rank will get 80% of discount, and up to 500 will get 70% of discount मिलेगा. And so up to 1000 वाला will get it as what will be now 65% discount मिलेगा. So you can plan your Unacademy subscription before it going to expire. And let's have a great learning experience from the top educators. You can see we started a new batches, that is Airport Authority of India के लिए हमने नया बैच हमने शुरू किया. You can join this batch by just 3,999 only. And these are the top educators team. You can find the top the top educators of India आपको मिलेगा, एक फ्रेम में आपको दिखेगा. You can have a look at. Okay. And we are starting a new batches and do enroll for these classes. And so the student we have taken Unacademy subscription आपके लिए मिलेगा टेस्ट सीरीज फ्री में मिलेगा completely. So part test 29, subject wise test 10, and advanced manner 10, multiple subject 6, mock length mock test we have a 10, and PYQ का टेस्ट भी PYQs 11. टोटली आपको मिलेगा कितना हिया 77 टेस्ट सीरीज आपको मिलेगा in the electronics and communications. The test series has been started from the April 1st onward शुरू हुआ. Even if the student who is enrolling now also can able to avail this opportunity, and you can attempt all the previous tests also. You can able to utilize them, right? And Unacademy is offering the plus subscription as well as iconic. प्लस में आपको लाइव डाउट टॉप एडुकेटर क्लासेस मिलेगा, लाइव डाउट, स्ट्रक्चर्ड कोर्सेज एंड टेस्ट एंड अनलिमिटेड एक्सेस. आइकॉनिक में इसके साथ और भी ज्यादा मिलेगा. क्या मिलेगा? यू कैन सी नाउ हियर 1-to-1 मेंटरशिप एंड फिजिकल नोट्स भी आपको मिलेगा. To avail this mentorship, book a slot according to your time convenience and discuss with the educators. You can start your serious preparation. So these are the GATE 2025 rankers from Unacademy. चलो आज का सेशन हम शुरू करेगा. Right. So today we are discussing the next topic, that is called as what has been Newton's laws. First of all of you do like the session, everybody. All of you do like the session. Do like the session, do like and share to all your friends. Let's see now here first. आज हम डिस्कस करने वाला द टॉपिक व्हिच इज न्यूटन्स लॉज. न्यूटन्स लॉज, द न्यूटन्स लॉज ऑफ मोशन. Right. So, सबसे पहले the first topic is the important thing. What we are going to discuss is the concept of movement. The concept one we are discussing linear momentum. Linear momentum. Linear momentum कौन सा चीज है? We'll see first. Yes. Linear momentum. Linear momentum, which will denote with a letter of P, is a vector quantity P bar, and which is given as this is a product of mass of a body into velocity. Linear momentum is given as what? The product of mass into velocity is called as a linear momentum. Mass into velocity. And you can tell me the units. The units of linear momentum is what is mass. Mass is what I know kg, and velocity is what? Meter per second. And dimensional formula, mass means what I mean here? M power 1, L power 1 and T power minus 1. Right. If initial momentum is P1 and final momentum is P2, then change in momentum that is given as what I mean of delta P. Delta P, the change in momentum, which is given as P2 minus P1. Yes, in these two are vectors. These two are the vectors now here. Change in momentum. These two are the vectors. Change in momentum P2 minus P1. Yes, first of all, is the audio videos clear to everybody? Do like the session, everybody? And change in momentum delta P. The magnitude of change in momentum, which is given as what? Tell me, square root of P2 square plus P1 square minus 2P1 P2 into cos theta, where theta is the angle between the two momentums. Theta is the angle between the momentum P1 and P2. Okay. Now here, consider the situation, case 1. Case 1. If a body of mass m moving with a velocity v, moving with a velocity v, hits the wall and comes to a rest. Then change in momentum. Tell me now. I have a body of mass m and which is hitting the wall. Right. And so this is a diva, a ball of mass m moving with a velocity and which is moving with a velocity v, and it will hit the wall. After that, after hitting, the velocity of this ball becoming 0. It is falling like this initially, and this final velocity which will becoming 0 completely. So you can tell me now here initial momentum before hitting the wall. The initial momentum is p1, which is given as what we can say now m into v. And after hitting the wall, the momentum is becoming what? Tell me now 0. Now you can tell me the change in momentum, that is p2 minus p1. So that is given as what we can say 0 minus m into v. So then delta p, which is equal to what? Tell me now here minus m into v. And this is the change in momentum. Okay. Next one. Case 2. Now let us consider a body of mass m. If a body of mass m with a velocity v, let us say it is moving with a velocity, initial velocity, we are calling that something v1, and hits the wall and hits the wall and rebound rebounds with a velocity v2. Then change in momentum. change in momentum. In this case, what they given here, and this is a wall. It is hitting, a ball is hitting this wall with the initial velocity of v1. After hitting, and this ball which is moving, and this is the velocity, this is v1, and this is the velocity, and this ball which is moving this direction after hitting v2. So you can tell me now initial momentum. We call this is an x-axis and this is a y-axis. Now opposite is negative x-axis, negative y-axis. So we can see now here the initial momentum pi, which is given as what we can say now here m into v1, and this is along what direction now here, x direction, positive x direction. That's what is I cap. And after hitting, the momentum is what, tell me now here, m into v2, and this is which direction now here, minus x direction. Then the change in momentum, that is delta p, which is given as what, p2 minus p1, that is delta p, which is given as p2, that is m into v2 I cap minus m v1 into I cap. So then delta p, which is equal to minus of m into v2 plus v1 into what, tell me now, I can. This is the change in moment in this case. Okay. Completed all of you? Yes, all of you do like the session. Do like the session, everybody. Hmm? Like the session and share to your friends. Completed. Next. Let's see the next one, next concept. Concept 2. Concept 2, Newton's law. That is Newton's second law. Newton's second law. Newton's first law is the law of inertia, and the Newton's second law. The Newton's second law, which is what, tell me, the change, rate of change of linear momentum of a body is directly proportional to directly proportional to the external force acting on it. So that means what will be the rate of change of linear momentum, that is equal to directly proportional to the external momentum. So external force acting on it, that is dp by dt. The proportionality constant, that is k into dp by dt, where this k equal to 1. So then F will becomes what, tell me, dp by dt. This is the Newton's second law. So the force acting on your body is given as what, you tell me, that is F, which is equal to dp by dt, where p is a momentum, that is this we can write it as dp. Momentum is given as m into v. If m is constant, we can take outside now. So then F is equal to what I can say, m into dv by dt. So this rate of change of velocity is called as acceleration. So that is F is equal to what I can say, m into a. From this, right? So this is the force. F is equal to what, tell me now, ma. So from this, what I can say now, a, where this a, which is given as what, tell me now, F by m. In general, what we can say now, acceleration of a body, which is given as generalized manner, I can say this as net force. Net force by total mass. Net force by total mass. Okay. Completed all of you, copied everybody. Huh. Now based upon this, let's see some of the example later. You can see. So consider I have one block. This is a block and a block of mass m, which is placed on the ground. Let us say that initially this block is at rest and we applied some force on this block this direction. A force of F is applied. Now I need the acceleration of this block. What will be the acceleration of this block? You tell me now, acceleration, which is what, tell me now here. So total force or net force we can say. Net force by total mass. Net force by total mass. And for the net force acting on this block, you tell me now here, F by total mass, we have only one block now, that is M. Now let us consider some other scenario. Let us say they given right? So we have this block, a block of mass m. Let us say a force of F1 we applied in this direction and a force of F2 we applied in this direction. Now we need the acceleration of this block. Then acceleration of this block, which is given as what we can say, that is net force by total mass. So you can see the net force. Consider here this is positive x direction F1, that will be taken as positive, and these are opposite direction forces. So what will be the net force, you tell me now here? That is F1 minus F2. My total mass is what, tell me? M only now. Total mass is M. Okay. Net force by total mass. Understood this thing? Tell me. Yeah. Now consider some other case now here. Let us say here is a block. Now assume that the two blocks has been placed like side by side. Two blocks has been located and both blocks are in contact each other. And let us say this mass is m1 and this mass is m2. We applied some force F on this block, that force is F. We need the acceleration of this block. So tell me the acceleration of this block is what we can say in this case. The acceleration of the block. Acceleration of both the blocks, we can say. So the blocks will move together now. These are in connection. So this acceleration means what will be now? Net force by total mass. Net force is what we have. Tell me, only one force is acting on these blocks. Net force by total mass. So total mass is what we can say now, m1 plus m. Net force by total. And so sometimes they may ask this some other, they'll ask the contact force, they may ask. Contact force means the force between these two blocks. So here when this block is applied, we apply the force only on this M2 block only. The M2 block is applied, so then there is a force between these two. These two are connection now. This block will apply, M2 will apply some force on M1 also. That force is called as what element of contact force. How much the contact force we can say? Contact force between M1 and M2. That force, contact force, which is given as, we apply the total force is F we applied. इसमें this acceleration of this block is A. So this is M2 into A. The remaining force will come to here. Okay. So that means what we can say now here, contact force Fc, which is equal to F minus M2 into A value we got. Now that A value we can substitute here. That is M1 plus M2. By simplifying, you can get the value of Fc of formulator. Okay. Understood this way? Uh, Completed everybody? Next one. Now the same thing, let us extend further number of cases. Let us say more cases we are extending here. The same concept. And consider we have the blocks like this. We have seen the two blocks. Let us take the three blocks. The same thing can be applicable for any number of blocks also. All these are in contact. Okay. So let us call this is here, and this block mass is M1 and this is M2 and this block mass is M3. And assume that we apply the force on this block. This force is F we apply. Okay. Then you tell me now what happens when we apply some force of F on this M1. M1 pushes the M2. At the same time, M2 pushes the M3. Like this, it is like a one will apply the force on other one. And there will be a contact force between the F1 and 2 that I am calling as F1, 2. And contact force between 2 and 3, I am calling this as F2, 3. Okay. Now you tell me, first of all, we will find the acceleration of the system. Acceleration of three blocks. All the blocks will move the same acceleration. So that should be given as what tell me acceleration is what tell me now net force by total mass. And with the net force acting on the all the blocks is you tell me now F is the net force acting now. And the total mass is what tell me now M1 plus M2 plus M3. The total mass is M1 plus M2 plus M3. And okay, next now let us find the contact force now here. Contact force, and what the contact force between the two blocks, you tell me? Between M1 and M2. So this will be called as F12 if I say. And if the total force we applied is F we applied, and this M1 will take some force, and that is how much will take here M1 into A, that is taken by the block 1. So then that is a contact force between the 1 and 2. Now similarly you tell me the contact force between M2 and M3. So that is what we can say now here F23, F23, and which is equal to what, tell me? That is F minus, tell me now here total force. This fellow share is how much, you tell me now M1 into A, this fellow will take. And this fellow will take how much, you tell me now M2 into A. Remaining will be passed to the M3 block. That is F is equal to what we can say here M1 into A of the first block will take, M2 into A second block will take. The total net contact force F23, what I can say, tell me now here, F minus M1 plus M2 into A. This is the total contact force between M2 and M3. Right? Next one. Now you try to answer this thing. Now the two blocks has been placed like this, and this mass is m1, this mass is m2. Now let us assume that a force of F1 we applied in this direction, and another force of F2 is applied from this direction. Okay. Now we need the acceleration of the block. Tell me the acceleration of the blocks. Acceleration A, which is given as net force by total mass. But the net force now F1 and F2 are opposing each other now. I'm taking F1 as a positive, F2 as a negative, then it is M1 plus M2. Okay, net force. And there is a contact force between them now. This is Fc. And what about the contact force? You tell me. Contact force between M1 and M2. How much you tell me? This contact force, which is given as, so this is F1 we applied, and it will take M1 into A. Okay, this is the contact force. And first we will find the acceleration. That acceleration will substitute here. Then we can get the contact force. Okay. Completed. Let's see the next one. So some other case they will give the problem like this. That is also exactly similar to this. What they do here, the two blocks are there like this. Here the two blocks are not in contact. These are not directly in contact, but these are connected by a string like this. Okay, this is M1, like a railway coaches. Now let us say we applied some force of F, we applied on this one block, either M1 or M2 anyway. Let us consider. Then when this force we applied on M2, now this, because of this direct connection, certain force on this M1 also, and this force which we can call it as a tension. That force, the tension in the string will call. Here earlier we call as contact force, that is here we are naming that as a tension. Exactly same analysis here also. Now you tell me now acceleration in this case. Now you tell me in this case what will be the acceleration. Net force by total mass. Net force by total mass of the system is what? Tell me, M1 plus M2. And whatever the tension, you tell me. Tension in the string. Tension T, which is equal to same approach. We apply the force of F we applied, and this fellow will take certain amount. How much will take here? That force is a M2 into A will take. So that is what we can say now, M2 into A. That is the tension. Okay. Tell me, able to understand or not? Tell me, facing any difficulty? Next. Now let's the same thing for the, if it is a 3 blocks given, same approach for 3 blocks also. And let us consider we have a 3 blocks like this we have placed. And so let us call this is M1 and this is M2 and this is M3. A force of F is applied and all these are connected by a string like this. All assume that string is very tight. Okay. Now you tell me first of all acceleration. Acceleration A, which is given as net force by total mass. Net force by total mass, which I can say here M1 plus M2 plus M3. And so here tension, here in this one, tension which I am calling it as T1, and here the tension I am calling this as a T2. Now you tell me the tension between the 1 and 2. This tension T1. Tension T1, which is given as what may have total, we apply the force of F. And this fellow, how much is the share of this fellow? You tell me. How much this fellow will take here? M1 into A will take. So that will subtract M1 into A. Next, you tell me now tension T2. And this fellow will take how much you tell me now M2 into A. So then what we can say now F is equal to what we can say here M1A minus M2A minus common, that's why it is plus. So the tension T2 which is given as what we can say now F minus, here tell me now M1 plus M2 into A. Okay. Understood everybody? Now, so extension of this thing here. There will be another kind of way, same concept, another kind. So they will use this as a pulley. and here this is the fixed here. And we have connected the two, at the two ends we have connected the blocks. Let us say this is M1 and this is another block we have connected, that is M2 we have connected here. M1, M2. Now assume that here M1 is greater than M2. So that's why what happens, you can see now here, and this block will try to move down. As this is move down, this block will move upward direction. You can see now why this block is moving down now, because of its weight. How much this weight of this block is? mg. And what the weight of this block, you tell me? That is m2 into g. This m1g try to make the string move this direction, m2g try to make the string this direction, and there is a tension in the string. The tension is T, same string, so the tension remains same. Now that means this block will move with an acceleration A downward, this block will move the acceleration A upward. Now what will be the acceleration of the system? We have to see this thing. And tell me the acceleration is given as what? As usual, net force by total mass. Here you can see now m1g try to pulls right side, m2g tries to pulls the string the left side. So these two forces are opposing each other. So that means net force, that means F net by total mass, we can say now, total mass. So from this net force is how much, you can see now here, since M1 is more, so M1G is more, M1G minus M2G by total mass. How much we can say this as? M1 plus M2. So then this value which is given as what we can say, tell me now, M1 minus M2 into G by M1 plus M2. Okay, this is the acceleration of the system. And we need the tension in the string. Tension, tell me the tension के लिए same approach. Tension T, which is nothing but M1G is downward direction minus this fellow is weight is what only M1 into A. This fellow share is what you tell me now, M1 into A. And the A value we calculated from this here now. That A value we can substitute here. Yes, visible now completely slide. Yes, this is M1 plus M. Yes, done everybody? Next concept. So first case we have seen Newton's second law. Some problems we have seen and understood this thing. So in the exam, they will give the values will come. That's all, nothing else. Next one, concept 3. apparent weight. Apparent weight of a body, right? So first of all, you might be know about the working of a weighing machine. Weighing machine, it will show the weight based upon the normal reaction. Okay, so if I consider this is some weighing machine, let us say this is a weighing machine. When you stand it on the weighing machine, when a person is standing on the weighing machine, so the weight of this person which is mg downwards, and there is a reaction, normal reaction. So this the weighing machine will measure the normal reaction. It does not measure the actual weight that we are going to see now here. So if it is at rest, let us say, so then normal reaction, the weight of a person, the weight of a person which is equal to weight W, that weight which is equal to what I mean normal reaction always, which is equal to what I mean now mg. So when it is at rest, the normal reaction is mg only. Now let us say some other cases now here. So the weighing machine which I kept in a lift, and the lift is moving upwards and downwards, it is moving. Let us consider. Now let us consider here if lift wing upwards, upwards with constant velocity. Constant velocity is moving. Then that means what happens now here? Assume that this is the lift. Inside the lift, we have placed the weighing machine. Inside the lift, we have the weighing machine is placed. And so on this weighing machine, so assume that a person is standing. A person is standing. And this is the weighing machine. And the lift is with a constant velocity. Constant velocity. That means what I mean? It is constant velocity. Acceleration is how much? 0. Then weight of this body. So here in this case, normal reaction is how much here? mg only. So then apparent weight is what? Apparent weight. Yes, W, which is equal to what? Tell me now, mg. Okay. Now let us consider the some other cases. Now here, let us say now here case 2. Case 2, when you have considered, if the lift is moving upwards with acceleration, with some acceleration which is lift is moving. In that cases, what happened? You tell me now here. In this case, there is a lift and this is the weighing machine. So on that one, a person which is standing, and this is the weighing machine. and here the lift is moving upwards with some accelerations. Now you tell me now weight of this body which is downward direction and the normal reaction is upward. Now what is now acceleration which is given us basically net force by total mass. Net force is how much here? Net force is N is normal reaction is upward direction, mass that is mg, weight by mass is what will be now m. So it will come to be ma, which is equal to what will be now n minus mg, and from this n is equal to what we can say, tell me, that is mg plus ma. So that n is equal to what I can say now m into g plus a. This is a normal reaction. Then lift will the weighing machine will show this is the reading will show. Then what I can say, apparent weight is equal to what element of here, w, which is equal to m into g plus a. This is the reading. That means the reading which is more than the actual reading. So that is w. If I take the g also common, this is mg into 1 plus a by g will come. So this is the apparent weight w dash. If I say this is the mg is a true weight plus 1 plus a by g. Now you tell me now here, if the lift is moving downwards, what happens? If the lift moving downwards, with acceleration A. In that case, you can tell me now here what's the scenario can happen. And the lift is going downwards and weight of this body downwards and the normal reaction upwards. So in this case, acceleration which is given as what? Net force. mg is a downward direction now here. mg minus n by mass. That is ma, which is equal to mg minus n. So n is equal to what? Tell me now here. That is mg minus ma. So that means n is equal to m common, that is g minus a. Now the apparent weight. And what is apparent weight now? Tell me. That is w dash, which is equal to m into g minus a. That means it is less than the actual weight. That is mg into 1 minus a by g. So this is w dash is w is the original weight 1 minus a by g. This is the actual weight of a work. The weight it will shown by the weighing machine. So you can observe now here the weight of the person in this case when the lift is going downwards. What happened? Less than the actual weight. You observe here. When the lift is going upwards, the actual weight is more than actual weight. If the lift is at rest, then actual weight only it will show. Okay. Done everybody? So in the exam, what they will give here, difference you can find. They may give the values, they may give. Problems may come. Okay. Done everybody? Understood? Yeah, that's it for today's sessions. And the next session we'll see the some more problems we'll discuss in the on the Newton's laws topic. Next, we'll see the frictional concept. We'll see, and circular motion concepts. Okay, sure. Okay, then see you. Bye bye. Good night.